Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Colors in the Night, 14 by Vilsa. And we've done a lot of these, actually. I love coloring puzzles, and even though this is anti-night, which I'm very bad at, I'm not good at solving anti-night puzzles. I enjoy the coloring aspect so much that basically I will force myself to do these puzzles because it's a very good solve. It's just the problem is I'm just not good with anti-night stuff. Anyways, let's get to the rules. We have normal Sudoku rules apply, which means place the digits 1 through 9 once in every row, column, we can get a column here, and 3 by 3 box. We also have, in addition, we also have anti-night rule set, where cells separated by a knight's move in chess cannot contain the same digit. So, for example, if this cell, in addition to having no repeats in any row, column, or box, can also not contain repeats in that are a knight's move away from it. So that would be these 8 cells. And that's how anti-night works. It's the bane of my existence because it's very popular and I'm not good at it. So that I tend to not do these. This is the only series that I consistently do, even though I know there's anti-night rules in them. Anyways, that is anti-night rule set. We also have XV, where cells separated by a V sum to 5, and cells separated by an X sum to 10. Not all V's and X's are necessarily given. So, for example, if this were, say, a 3, this would have to be a 2, because these two digits add up to 5. If this were, say, a 3, this would have to be 7, because we know these two digits add up to 10, because there's an X in between. And that's how XVs work. We also have palindromes, where digits along a gray line must read the same forwards and backwards. So it could be something like, say, 2, 2, 6, 6, 2. Or it can't be 2. 6. It could be 2, 6, 6, 2, which reads the same as 2, 6, 6. Sorry. 2, 6, 6, 6, 2, or 26662 reads the same either way. And that's how palindromes work. And then finally, we have Kropke dots, where cells separated by a white dot are consecutive, and cells separated by a black dot must have a 1-2 ratio. And not all possible dots are necessarily given. So, for example, if this were, say, a 6, this would have to be a 5 or 7, because these digits must be consecutive. If this were, say, a 4, this would have to be a 2 or an 8 to maintain the 1-2 ratio between them. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, these two digits add up to 5, so it's 1 through 4. That means this is the same as this, so this is 1 through 4. We're going to mark this as an A. This is B. These are the same, so it's C and C. We have D and D, E and E, and these are F and F. Okay, so those are the only palindromes we have. This is 1 through 4 here also. C, D, and E are different. F and F could be different. E cannot be here or here, so E has to be one of these 4. D cannot be here or here, so D and D could be one of these 4. C cannot be here, C cannot be here, so C is one of those 4. Okay. A cannot be here, so A is one of these 4. A cannot be here or here, so A is one of these 4. Okay. This cannot be a 2-4 pair because that would eliminate all possibilities for this V. That would eliminate 1, 4, and 2, 3. But it still could be, it cannot be 1, 2 for a similar reasoning. Okay. Right, if it's 1, 2, that eliminates 1, 4, and 2, 3 as possibilities for the cells surrounding this V. So no 1, 2, no 2, 4. So this must be either 3, 6, or 4, 8 here. So we're guaranteed a 3 or 4 here. Okay. So this, whatever digit that's 3 or 4 here, cannot be this one. This is a different set. So we're going to mark this as green and orange. This is the orange set of 3, 4. This must be the orange set of 3, 4, which means we're guaranteed the orange 3, 4 to be in one of these 3 cells here. Okay. It cannot be C, because C is these 2 digits, and therefore it cannot be that one. So this can't be 3, 4. So the orange 3, 4 is one of these 2. Hmm. Um. Hmm. These digits are consecutive. So it could be 5 there. We are not certain. We have anti-knight. Right. Okay. So A. This is A. It cannot be either of these digits here because of anti-knight. So A cannot be here or here. Again, it can't be here, it can't be here because of normal Sudoku, can't be here because of anti-knight, so it's one of these 2. So that means A has to be one of these 3 here. And it can never be D, so this cannot be D. D cannot be either of these cells here. So this is D and this is D. So this obviously can't be E again. So D eliminates D here by anti-knight. Cannot be here or here by normal Sudoku. Can't be the same as A because of anti-knight. So this is D and this is A. A cannot be here because of anti-knight. So it's one of these 3 cells. F and F are here, so F has to be one of these 3. E cannot be here and here because of normal Sudoku. Can't be here because of anti-knight, so it has to be this cell. So this is E, that's E, which forces one of these 3 cells to be E. B can't be here. B can't be here by normal Sudoku. That's not helpful. B can't be here or here. So B has to be one of these 4, and it obviously can't be A. So this is, well, this is not necessarily A. Okay. B is not here or here, so B has to be one of these 4, but that's not helpful. Okay. A is one of these 2. So this is guaranteed to be D. So since this is D, this cannot be the green pair. This must be the orange pair. So this matches this. So this is a green. So this is 6, 7, 8, 9. This cannot be A. This still could be F. So this is 1 through 4. This is 6 through 9. Okay. This is also the green, which means D has to be one of these 3. This has to be, one of these is A, so this cannot be A here, therefore A is here. And this is orange, A. Okay. That means this one that matches here cannot be any of these digits here, cannot be any of these digits here, so this is also the other orange. Low. Okay, so A is here, so A. This can't be A because of so A is one of these 2. It's here, obviously. A cannot be here. A cannot be here because of normal Sudoku. Knight's move there. Can't be here. So A has to be one of these 4. Cannot be C because of knight's move. So it's one of these 3, actually. D's here, D's here, D's here. D obviously cannot be here or here. It cannot be B. So D can't be here. D can't be here because of knight's move. D can't be here because of B. So D's one of these 2. And these 2 cells both see this cell here. This one by knight's move, this one by normal Sudoku. So this cannot be D. D is here. D cannot be here, so D is one of those 2. D can't be here or here because of knight's move. So D has to be one of these 2, which eliminates D here. Therefore, this is D, so this can't be D, so this must be D here. So we have D here, D here. These are D, that's D. D has to be one of these 2. And if this is D, these 2 add up to 10. Therefore, this would be the same digit as that. So this cannot be D. Therefore, this is D, not orange. So this is the 3, 4 orange. This is D with this digit here. So these match. I don't know, I'll make it dark. So D's here. This means that can't be D. So this is D there. D cannot, D is one of these 2. D has to be one of these 2. But if this is D, that's with F, or sorry, dark, and therefore I eliminate that, and there would be a contradiction. So this must be D here. So this cannot be D here. That's D there. So these are all done. I guess we should make this the, well, we'll make this the green that goes with the D. Right? The high digit. So we'll make this green and red, I guess. The red, we don't know where that is. Okay, cannot be here. So this could be A here. We're not sure. A cannot be either of these or here, so A is one of these 3. It doesn't tell us much. A is one of these 2. A is not, okay, so where is A in column 7? It cannot be here because of knight's move and normal Sudoku. Can't be here because of the 10 that the D adds to. Can't be any of these because the A's in the row. So the A has to be one of these two. So this is guaranteed to be A and its corresponding thing. So we'll make A. We'll make A actually pink. So this is a pink pair. We don't know which one of these is pink. Is the low A. So this could be pink also. We don't know. A has to be one of these three. And A has to be one of these three. So A is one of these two, guaranteed. Okay. A has to be one of these three. D high is one of these, or green high is one of these. So green high must be one of those. This cannot be orange. This cannot be pink. This must be red and red. Because it can't be green either. High green cannot be here or here or here. So high green is one of these two. We don't know which. So low 1 through 4 is one of these two. We don't know which. Yeah. What else do we have? So this is pink and pink. This is green and green. So this must be either both orange or both red. We don't know. Okay. So this is orange. So we don't know if this is orange or this is orange. So this can't be orange here. Orange could be any of these 5, I think. Cannot be here, but it could be any of these 4. Not too helpful. Okay, whatever digit is here cannot be obviously here or here. Can't be the same as this one. So it must be the same as one of these 3. Not sure which, though. So E is here, here, and one of these 3. Oh. Huh. Interesting. Okay, this sees both greens. These two cells see both greens and both reds. So none of these could be green or red. The other green has to be one of those two, right? So one of these two is the other green. So either green is one of the high green is one of these two, or it's both of these. We don't know which. Interesting. Hmm. That means E cannot be either of the reds or either of the greens. And if E is 6 or 8, how does that work? Okay, so say E was one of these two. If that's the case, if E were one of these two, say it's 6, it cannot be green or red. So say it's 6, that means that it must match with these to add up to 10, because we already counted the green here and the red here, both adding up to 10. And they add up to 5 amongst themselves. So say it was 6, then 6 would have to be 4 to match it to add up to 10. 1 and 4, but the problem is the 3 or 4 here would have to be a 3. So that doesn't work. If it's 8, that means E is 8, so this must be a 2-3 pair, but then neither 2 or 3 can be here to be in 1 and 2 ratio with 8. So E cannot be either of these cells then because of that. So E has to be here, which means this cannot be A. So this is E. Oops. Remove the coloring. A has to be one of these two, which means this cannot be A. So this has to be A here. So A is the 3, 4 then. And then orange is the 1, 2. So this cannot be orange here. This must be A here because it matches the 3, 4. So this is A, which means neither of these can be A. So that guarantees A here, so this can't be A. That's orange, which means this can't be orange. That's green. Or pink, which eliminates A here. So these are both pink, but this is the A. So now we know this is A, this is A, and this is A. This has to be the 3, 4. This is the 6, 8 with it. This is E, whatever that is, which is either orange or pink. We don't know which. But the high orange or pink. This is orange or pink. Orange or pink. Orange or pink. Okay. So this is pink in A, so A cannot be here. Therefore, this is guaranteed to be A. Orange. So the orange 1, 2 is one of these two. B could be the other red. We don't know. This is high green. What is this 6 and 8 then? Obviously cannot be B. Can't be in this column. Can't be in this row. Can't be D, so it's one of these 4. Oh, that's interesting. Okay, so orange cannot be here. So orange has to be one of those two. Hmm. This is E. C could be the same as F. That's technically possible. Hmm. So this digit is either here or here. Interesting. Um. Huh. This digit cannot be this cell. Well, we already knew that. I don't know why I said that way. Um, hmm. So say this was C. I think that's possible. So that would be C. This would not be red. So it would have to be orange and orange. So this couldn't be orange here. One of these would have to be red. The other one I think would have to be 5, and then this would be red. That seems plausible. So obviously this is C, this would be C. Um, it still could be the same as F. Hmm. Um, okay. So let's say it's actually F guaranteed. So if this is F, that's F here, so this cannot be the green. So that's orange, orange. So obviously this is not that orange. F is there, F is here. F cannot be here, so F has to be here. Therefore, this can't be orange, and this must be the F. So F is here then. So this is all F, which means this is F. F cannot be, this is F also. So that means that requires F to be there, and that is valid. What happens if it's not F is kind of the question, right? So say it's here. That means this is not the low 1, 2. Okay, so this is the low 1, 2. That means it cannot be here. It's not E, so it's one of those two, right? Uh, okay, say it was... Okay, so if it's C, that means C and F are the same, right? Because... does that make sense? If this is C or... Yeah, if this is C, either of C or F, it has to be the other one, right? Because it can't be here. C would be... Well, okay. So if it's C, I guess it doesn't have to be there, does it? Can't be there, so it's one of these three. Um, huh. Say it's here, then it can obviously can't be F. Right? Because this sees this cell by normal Sudoku and this cell by knight's move, anti-knight. So if it's here, it's guaranteed to be here. So we can, okay, so F, or this orange, is either here or it's one, or it's this one. It cannot be this one actually because it's E. So it's either one of these two or this one. And the thing is, it cannot be this one because if it were here, the problem is this would have to be a cell, the same cell, and it cannot be either of these cells, so it can't be F, which means it has to be that cell. This is not A. This is 1 or 2. Cannot be here, cannot be here. Oh. Well, I guess it could be either of those. So orange low cannot be either of these, cannot be here, cannot be any of these. So it's either here or it's one of these two. Um, hmm. Hmm. So this has to be 6, 7 here. Okay. Again, if it's here, it cannot be F, so it's here. So this can never be orange. One of these two is that low orange. Okay, so B obviously can't be that digit. Um, okay. If it's these two, so it's either here and here or it's here and here, right? If it's here, this obviously this can't be the orange, low orange, so this is the low orange. If it's here, that means it's this, it cannot be here, so it must be the same as C. So C and C have to be orange. Cannot be here because of knight's move, so therefore it's the same as F. So C and F are the same if this is orange, if it's orange. If it's here and here, that's the interesting part. That means it's also here. So that means this can't be orange, this can't be orange. This can't be because of knight's move, so this would have to be orange here. Which would mean this is orange here. I mean, that seems feasible. Okay, so where are the low 1, 2s? Okay, so we're gonna remove the E coloring. We know it is the high. Actually, it could be 5. It doesn't have to be. So it's not red or green either way, but that's all we know. It doesn't actually have to be 5. So this is low 1 or 2. Sorry, low orange. If it's C, it must be the same as F. So then, right, because if it's C, which is here, that means it's not here, so it has to be there. It must be here and here. It cannot be here because of anti-night, so it has to be F. So then these are the same. So you would have orange here, orange here. And then the remaining, so this would be orange, orange, orange. So these two would be low, orange, low orange. That would force this to be orange here. Okay, so that's if it is C. If it's not C, it's this one, which means it's here, which means it's here. So cannot be here or here. Can't be E, so we should just mark it as E. So if it's here, that means it's here also. So it cannot be either of these. Can't be here because of knight's move. Can't be D, can't be E, so it must be here. Okay, so that means we're guaranteed. So if it's here, which forces it to be here. Yeah, remember, so it's here, here. That means none of these can be orange. Cannot be here. So I think it has to be one of those two, if that's the case. So then it would be here and here. It would be here. So cannot be here, cannot be here. Can't be here or this. It cannot be here, so it would have to be this one. Interesting. Huh. That's interesting. So, okay. Either this is 1, 2, 8, 9. And these would both be orange, so we would cannot have both reds here. So this would have to be 5 with 4 or 6. That's interesting. So then A would be 3, 7. And this would be 2, 8 here. So that's possible. And this would be the other red. So it'd be 4, 6. Otherwise, this is 1, 2. It must be with the other 1, 2, which is red. To be consecutive. E cannot be the same as B. So E cannot be here. It cannot be here. It can't be here because of night tied night. Can't be here. So E is guaranteed to be here. E cannot be the same as high green. Can't be here. Can't be here. Can't be the same as orange. So this is E. Okay, and there we go. So then we know it matches with the 1 and 2 to add up to 10 because E cannot be red, cannot be green, so it can't be double pink. So it has to be these are orange. So this is orange here, which means this cannot be orange. So this is all C, which is the same as F. right? Cannot be here. This is C, so this is not orange here, which means this can't be orange here. This can't be orange here. Cannot be here because that's a knight's movable anti-knight from C, so this is the same as C. This is not green, so this is orange, which means this can't be orange here. It matches this because this can't be F, so that matches this. So this is the high green. This is C, essentially, that's C. And this is C. And we know it's a 1-2, so let's leave that open. 3, 4. E has to be the high orange. So E is high orange. Cannot be here. This is E. E can't be here. E can't be here or here. So E is one of these two. E cannot be here by knight's move, anti-knight, and can't be here and here because of E in the columns. So E has to be here. E cannot be here. E cannot be here. E is one of these two. Okay. That doesn't tell us too much, but unfortunately, that's what we have. So B is not the same as the high green because these are in the same row, so this cannot be B. So this is B, this is B. So this can't, okay, so this can't be B. B can't be here, can't be any of these, can't be E, can't be A. So B has to be one of these two. We don't know which. Okay, C cannot be there. Huh. This is high green. Guess we could call it H, I guess. You know, so B has to be one of these two. B then must be one of these two. B is one of these three. B cannot be here, so B has to be one of these four. This B sees these two cells and this cell by anti-knight, so this cannot be B, which means B has to be one of those two, so this can't be B here. So B is one of those two, B is one of those two. B cannot be any of these cells here. If it were, it can't be C, can't be D, can't be A. So therefore, where is B in row 3? It has to be here. So this cannot be B. Okay, well, there you go. That's B, B, B. That means B has to be one of those three. Where is the... Okay, so we're going to mark the high green as H. H cannot be here, cannot be here. Can't be here because of anti-knight, so H has to be here. That means this is a BH pair here. So this is B and H, this is B and H, and this cannot be H because of H in the anti-knight, so this is B, which makes this H. That means B is here. These are all B. Okay, H cannot be here. H is here also. H can't be here, H can't be here, so H is one of these two. Which means H cannot be here, H cannot be here, or here, so H is here. And that, by anti-knight, eliminates H from there, so this is H. H cannot be here, here, or here, so this is H. Let's make this F, I guess. And then we have G and I. So this is G or I. Let's make this G. We'll make that I. F is obviously one of these two. F is one of those two. This is I. which makes this a G. So this is G here. That matches that. So that's the 6/8. We're missing I. I cannot be here because of anti-knight, so that leaves the remaining cell as F. So this is F, this is I, this must be G. Okay. B is one of these, G has to be one of these, and G cannot be here because of anti-knight. So this must be F. So this is F, this is a B F pair. Or sorry, BG pair. F eliminates F here as anti-knight, so F must be here. So this is B or G here. We're not sure which. We don't know, obviously, if that's red. Remaining cells in column 3 are F and I. Remaining letters in column 4, we have A, B, C, D. So we have F and G. This can't be F because of F in the row, so that's G, which makes that F. Where is F in box 2? It must be here. This is G, this is I then. So we're missing I in row 3, so this is I. We have B and G here, B and G here. This must be a BG pair here, which forces this to be I here. Remaining cell in row 7 is an F. So whereas F in column 7 can't be here because of all the F's in the boxes, so this must be F here. So that's F. A and G cannot add up to 10, obviously. Oh, it's C and E add up to 10. A and G cannot add up to 10. A and B could. A and I could. So isn't this B and I? Okay, this is F, which eliminates F here. So this is I, that's F. We have B, G, and I remaining. In column 7. So this is BG or I. This is E, BG or I, and obviously this can't be I because of I in the row. This has to be a BG pair. This is BG or I, but it cannot actually be G because B, A, and G are in a 1:2 ratio, and they can't add up to 10 then if that's the case. So this is guaranteed to be G here, which means G cannot be in the rest of the box. So this is B or I. We have E, B, and G here. And this is BG or I. Okay. This is a BG pair. They both see that cell. This cell sees that because of normal Sudoku, and this by anti-knight. So this cannot be B. Therefore, this is I. So A and I are the pair that add up to 10. This cannot be I. This can't be I, so this is a BG pair, which means this can't be B or G. It's E, which forces this to be I. So we know this is 3 or 4. This is obviously A. This can't be E, so this is E here. So C and E add up to 10. A and I add up to 10. H and D add up to 10. G is the one that we know also must add up to 10. So F and G must be the ones that are adding up to 10. That means B is a 5. So B is here. This is G. B eliminates B here, so that's G, which makes this B. G eliminates G here, so it's B and G. B eliminates B here, so it's G and B. This can't be G, so this is B, which makes this G. So B must be 5 because it's not with any other digit to add up to 10. So B is 5. G then must be 6 because it's in a 1 to 2 ratio, and it must be consecutive with 5. So G is 6. Since G is 6, F must be 4. A has to be 3. I is 7. That means C is 2. E is 8. D must be 1. And H must be 9. And that's the solution. Yeah, I mean, pretty cool. It's interesting that this turned out somewhat similar to the example I gave, but obviously not completely correct. This was part of the 2-3 pair. These were all the same. That's interesting. But yeah, I always enjoyed these sort of coloring exercises or letter exercises. It's very interesting for me. I hope you found this interesting, and I'll see you next time on Frank Puzzles. Take care.